Greetings, everyone. This is Jeff Overson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of July 28th this time around. So basically half of the last week of July and half of the first week of August, the stars of fall are becoming more and more prominent. The stars of late summer high overhead. The year just whooshes on by as we watch the stars come and go. Pretty good moon week. It's filling out by the end of the week. It starts the first night, the evening of the 28th. The moon's less than 20% full, on the order of 20% full. And it sits below Mars and Zavi Java, a star that we've looked at several times in the Y portion, the upper portion of Virgo. And so this is a good chance. We're kind of giving up on Mars in the glow of sunset. This is a chance to get out there and help find Mars in that glow. Use your binoculars if you need to. Mars is about 1.6 magnitude. Zavi Java is third magnitude star. 2 nights later, the moon's over a third full, and it's near the bright star in Virgo, Spica. So watch it track out that way. On the evening of the 31st into the morning of the 1st, we're 45% full now, so it's going to stay up long enough to be thinking about it past midnight into the morning. So in the evening of the 31st into the morning of the 1st of August, the moon sits next to 4.8 magnitude ET Virginis. And ET Virginis, a couple of things to note about this star. With a half-full moon nearby, it might wash out. A 4.8 magnitude star isn't the easiest star to see anyway. If you've got any kind of light pollution or any kind of moisture in your atmosphere, any kind of haze, it's not simple. So you might want binoculars for this. I'm guessing you do want binoculars for this to find ET Virginis. It's going to be the brightest star just north and maybe, depending on what time you're looking, maybe a little bit east of the moon. And so this star is a variable star, and it varies from about 4.7 magnitude to 4.9 magnitude. This is interesting to me because of the research projects that I've been doing with students here for the past 20 plus years. We've been monitoring a number of stars in and around the in the field of the open star cluster M23 in Sagittarius, and we found dozens and dozens and dozens of variable stars, and most of them look just like this. A lot fainter than this, but they have this type of variability, which is semi-regular. It's semi-periodic. It gets brighter and dimmer with something of a pattern, but not a very repeatable pattern, and changing by about 0.2 of a magnitude. Very common type of star for us to see. So it's interesting that way. The other thing about ET Virginis, we can see from its Doppler shift. This is a shirt students gave me a long time ago. That goes on this way. So blue shift, if the star is coming towards you, the wavelength is getting shorter, and red shift, if the star is moving away from you, the stars, the Doppler lines in the star are shifted toward longer wavelength. We can see from that ET Virginis is moving almost directly away from us at a relatively high rate of speed. So the star is moving away from us, and right now it's about 560 light years away. It would have been at its closest approach to us somewhere on the order of 6 million years ago, and it would have been a lot closer. It would have been about 3 times closer, which means instead of being a 4.8 magnitude star, it would have been a 2.4 magnitude star 6 million years ago. So you invent your time machine. This is your homework for this week. This is your task. Go out and invent your time machine. When you invent your time machine, say, I think I'm going to go check out what he's saying. I'm going to go back 6 million years ago and see what ET Virginis looks like. It should be at 2.4 magnitude, brighter than any of the other stars of Virgo, except for Spica, big bright Spica, that dominates all of these. It's the next brightest star suddenly. Barely visible now, suddenly the second brightest star in Virgo, 6 million years ago, and brighter than all of the stars in Libra, which Libra lies to the east of where the moon is now, and the moon will be tracking through there over the next couple of nights. After this. So you look at where the moon goes over the next 2 nights, all of the stars in that vicinity, the closest star will be Zubayn El-Kanudi. It'll be near, but that would be a star that's a little bit, not a lot, but a little bit fainter than ET Virginis would have been 6 million years ago. So that's all great stuff. By August 3rd into the morning of the 4th, already 3/4 full and sitting very near the bright star, orange star Antares in Scorpius. So that's something to watch for as the week goes on. The moon filling out will be next to Antares. That warns us that by next week we were doing this, the moon's going to be a full moon week, and we're going to have a hard time observing some things again. So get out there and observe this week if you can. On the 29th, let's note the early morning of the 29th, Venus is sitting very near Mu Geminorum, and Jupiter sits just below there. So Jupiter should be becoming fairly easy to see in the morning sky, and you'll see this nice trio of Venus very near Mu Geminorum, and just below there a little ways is Jupiter bright. Venus and Jupiter far brighter than Mu Geminorum. So get out, check, and you're out early in the morning, check this grouping of objects out. So let's think about what we can see in the evening sky. You see here, it's the diamond shape of Aquila. And you're thinking, oh my goodness, will we ever stop drawing that? And you can see that even I want to stop drawing that because it gets worse and worse each week. I'm just slapdashing it on the board now. Like, all right, you know the diamond shape of Aquila with Altair, the bright star at the top of it here. What we've done in the past 2 weeks is we've dropped south down the tail of the kite there to find objects we want to look at. We're going to go north this week. So if we go almost due north, we probably have to track west a little bit, but if we go almost due north from the Altair region, about 8.5 degrees. Remember, a fist at arm's length is about 10 degrees, so a little bit less than a fist width at arm's length north of Altair. We come to the bright globular star cluster M71. And so this bright, it's a good globular star cluster. Any of these objects we're looking at are good objects for you to try to take photographs. If that's what you're doing, is taking photographs of the sky, M71 is going to be a good globular cluster to try. So it's nice and bright. You might be able to see it in binoculars. I suspect you can if you've got dark skies. You go another 4.5 degrees, 4 and 6 degrees to the north. Now you definitely have to cant to the west just a little bit. And if you do that, you come to M27. M27 isn't as famous as the Ring Nebula. This is the Dumbbell Nebula. This is a planetary nebula that has pushed off its outer layers, a star, that the shell of the star, the outer layers of the star they've lost gravitational contact with the core of the star, and that they've been pushed outwards and they're expanding into space. The Dumbbell Nebula is named, it really looks more like a bow tie to me. A bow tie nebula where it's neck down in the middle. Magnetic fields can constrict the direction that gases escape from this star. And this is a great example where it looks like a bow tie. And you can even get a sense of it in the eyepiece of your telescope without taking a picture. But again, if you're taking pictures, fantastic object to do that. Now, if you draw that line that connects M71, the beautiful globular cluster, with M27, great example of a planetary nebula that we're talking about right there. As you get up about halfway up the way between them and move over a couple of degrees to the west, you get to NGC 6827. This is an open star cluster, and this is a fun observing challenge. This is your challenge object for the week, is to go out and see if you can see this open star cluster. It's really far away. It's over 13,000 light years away. Compare that to the 560 light years of ET Virginis that we were looking at earlier. Over 13,000 light years away, a lot of open star clusters. For goodness sake, the Pleiades is an open star cluster. You see, that's huge, right? The Hyades, near it, is an open star cluster. We have all these open star clusters that we've been looking at over the past few weeks that are big. M11 was our best example of one that was beautiful in an eyepiece of a telescope. This one is really hard to find because it's so far away, it's tiny, and it's in a star-rich region of the sky, so that really it's a lot of faint stars behind it, and it's a region where the number of stars just increases a little bit. But having said that, it is visible, particularly if you're taking photographs. Again, if you're out there photographing, that's your challenge object of the week. Go find 6827 and see how much it's only 1 or 2 arc minutes across. We were talking about arc minute as a 60th of a degree. Your finger held out at arm's length as a degree. We were talking about this a couple of weeks ago. We were talking about sizes of globular clusters, and that's small. That's really small for an open star cluster. But it's got quite a few stars, 100 stars or so in it. And you see that 100 stars in a tight region. Noticeable increase in density of stars compared to the background. If you want to see what you're looking for, go out and Google some some pictures of this object. A couple of papers. I wrote down the names of the papers that I looked at, but I didn't write them on the board. So there's been a couple of papers. This is, looking at distant open star clusters, trying to understand the membership. The most recent one was James and Hoke in the Astronomical Journal 411, number 3, 2011, was a paper that several of these clusters, but NGC 6827 was in there. There was one 5 years earlier in 2006 in the monthly notices of the Royal Astronomical Society, number 371. Carraro, Subramaniam, and James were at St. James, as the other paper. We're on that one. So talking about membership of this. So people, this is an object that you want, we don't even know for sure how many stars are in there. Kind of hard to see, but if you look at those papers, you see how we can tell that there's a lot of stars there. So all of this is great. This is your object. Enjoy the moon passing these stars in the morning sky, in the evening sky, and in the morning sky, and then Mu Geminorum, Venus, and Jupiter in the morning sky. Use the diamond shape of Aquila this week to go north, M71, M27, NGC 6827, and that's what we got for you this week. So, as always, everyone, thanks for watching, and we hope you have a great week ahead.